Okay, here we go. All right, we're on page 3, number 6, our first example. Secant times cotangent. Uh-oh, we're not up on the screen. That's not going to work. Let me try again. Where are we? Okay, there we go. Now we're up on the screen. Secant times cotangent. What we need to do, our job is going to be to try to substitute things in place of secant and cotangent so that I can somehow do this multiplication. It's asking me to multiply these two trig functions together. And so I need to get terms that are common, terms that are alike, and then see what I can do. So first thing I want to do is take a look at your list of identities and see if you can figure out what is something that we could substitute in place of secant of x. Secant of x. It's not squared, it's just one single secant, and there's really only one thing that we can put in its place, but secant is the same as, you can look at your identities list, it's the same as 1 over cosine. So I'm going to replace secant of x with 1 over cosine of x. I've just substituted something else that it's equal to. Okay, let's do the same for cotangent. What can I substitute in place of cotangent? Good. That's the one I would pick. Cotangent has a couple of choices. It has 1 over tan, right? Or it could be cosine over sine. That's the one I would choose because I already have a term here that had cosine in it. So that's what I'm going to choose. See how this gets us off to a running start. Now I've got some multiplication, and this looks a little bit more reasonable to me. I see things in common. So if you multiply straight across the top, straight across the bottom, this is cosine of x times sine of x. We can just write them together. Then I notice that I can do what? I can cancel out the cosines. Yes, cosine over itself is equal to 1. You may have even noticed that before we did the multiplying. And so you're certainly, if you noticed it back here, then you can go ahead and cancel those out, knowing that they are equivalent to 1, so they cancel out. Now, when I go to write my next step, when I go to write what this is equal to, it looks like I have nothing in my numerator. But we know that nothing really means what? 1, right? We think there's nothing there, but there's really an understood 1 there. So what I'm left with now is 1 over sine of x. Okay, I'm not quite finished, but almost, because the simplest form is always going to be something that's not a fraction, if at all possible. And it's possible. So 1 over sine is equivalent to what? The reciprocal of sine is cosecant. Good. Cosecant. So I can replace 1 over sine with cosecant, and I'm done. I've now simplified this into simplest form, and that's what I'm looking for. Most of the time when we are simplifying, we're going to get it so that it's eventually in just one trig function, just one of our trig terms. Not always, but most of the time when we're simplifying. Okay, let's go up and take a look at number 3 on this page. Number 3 on this page. Okay, it looks different for me to see these trig functions this way. You always have to have a variable with the trig function. So whether it's sine, cosine, tangent, whichever one you have, there's always going to be a variable there because that's the only thing that makes it work. You have to have an x or a theta. Sometimes in the packet, you'll see some crazy ones like beta or alpha, just because, just trying to be different and expose you to different variables. But make sure that you always include the variable that's given to us. Now, this one, number 3, this has 2 terms. We need to think of this as one whole term. It says sine times cosine squared, but we consider that one term. It's as if I were to have, let's say, 3x squared. 3x squared has, more than one part, but we would consider this one term in a polynomial. So that's one term, and then it has subtraction, and then sine of x. This is 2 terms. So I have 2 separate terms, and it looks like they have something in common. They have something in common, and so I'm going to get us to factor out what they have in common. We're going to take the GCF, the greatest common factor, and factor it out. What do both terms have? Sine of x. They both have a single sign. So I'm going to take sine of x, I'm going to factor it out, like the opposite of a distributive property, basically. So if I take sine of x away from this first term, what's left over is the cosine squared of x. Bring down your subtraction symbol. When I take sine of x away from itself, what am I left with? 1. Good. It looks like nothing. It feels like there's nothing left. And when you say to yourself nothing, then I want us to always remember there really is something there. It's just the understood 1. So don't forget that, because that's super important. Okay. So now I've factored out the greatest common factor. My next step is going to be to see what I can substitute in place of anything that I have here. And I happen to notice that I have one of my identities, one of my 3 new ones. And I'll go ahead and tell you, my hint is whenever you see things, especially if they're separated by a parentheses or they're kind of off by themselves, anything that has a plus or a minus 1 with it is probably 90% of the time it's going to be a trig identity. It's going to be one of these 3 Pythagorean identities that we've just learned. So which one of those, obviously, of the 3 that I have on the whiteboard there, it'd be the first one. Sine squared plus cosine squared equals 1. I can move that around so that it looks like what I've got here, which is cosine squared minus 1. So we kind of have to think to ourselves, okay, here's my identity. I want to make it look like that. I want it to say cosine minus 1. So I have to move some terms around. If I subtract the 1 from both sides, I can get cosine squared theta minus 1. And then what I would have to do is subtract the sine squared to the other side, right? So it would be minus sine squared over here. So this little process, we kind of come over to the side and work it out and see that, okay, cosine squared minus 1 is equal to negative sine squared. So that's what I'm going to put in place of what's in my parentheses. I can substitute it in place of what I have there. So in my parentheses now, instead of cosine squared minus 1, I'm going to put negative sine squared, because those are equal to each other. So I can substitute it in its place. Good. So now what I bring down the rest of my expression, I have sine of x times negative sine squared of x. So I just need to do that multiplication. Sine times sine squared is going to give me, take a guess, sine to the third. Okay, all done. You can know for sure that you're finished when you are left with just one trig function, one term. All right, let me get you to try one. Let's flip over to page 4. And I want to go all the way to this one here, underneath where it says practice number 1. I'd like for you to simplify this expression. It says tangent times cosecant. So look at your identities chart and replace. Figure out what can you put in place of, what can you substitute instead of these things, instead of tan squared and instead of cosecant squared. Excuse me, they're not squared at all. Instead of tan or instead of cosecant. Now, I know from some previous examples that tangent has a couple of options. You know, it could be 1 over cotan, or it could be the more commonly used sine over cosine. So perhaps I would choose to substitute in place of cosecant first, since it only has one choice. There's really only one thing that I can put in place of that. Instead of cosecant, I can write 1 over sine. So now, because I have the sine in there, I'm going to replace tan with its form that has a sine in it, right? Which would be good. So now I've done my substitution. I can do multiplication now. Check to see if there's anything that I can cancel. This is our basic process. Substitute, do the calculations, look for what cancels, and then arrive at your final answer. Now, I don't want to leave it like this. I don't want to leave it in a fraction form if at all possible. That wouldn't be completely simplified. 1 over cosine is the same as what? Secant. Good. 1 over cosine is the same as secant. So this would be my final answer here. Okay, let's take a look at, let's go up. I like to jump around, obviously. Number 8 at the top of this page. Number 8. So we have a big fraction here. It's going to get even bigger. You go ahead, and I'm going to be quiet, give you a head start. Replace these two trig functions. Substitute in place of cosecant and secant the things that we know we can put in their place. Put in place of those the things we know they're equal to. So we should know our reciprocal pairs, right? We should know that cosecant is paired with sine. So hopefully I can easily substitute in place of cosecant 1 over sine, because I know it's its reciprocal. We've known that for a while, since we've worked with our trig stuff, since January probably. Secant, its reciprocal pair is cosine. So I can always replace secant with its reciprocal, which is 1 over cosine. So now I have this big ugly fraction, but it's not so crazy bad, because I can do keep, change, flip in order to calculate. In order to do that division, I can do keep, change, flip. We've done that quite a bit since unit circle stuff, right? So I'm going to keep the first fraction, 1 over sine. I'm going to change that division there. I'm going to change it to multiplication and flip the second fraction. Flip it over. Now do your multiplying. Okay. Almost finished, but not quite. I don't want to leave it in a fraction form if at all possible. Instead of cosine over sine, I should replace that with what? Cosine over sine is equivalent to cotangent. Very good. And that is, technically that's called a quotient identity. It's on our identities list. Very good. Okay, so they're getting a little bit easier. I'm starting to understand the pattern. Substitute, do your calculations, see what you can cancel, and come up with your solution. Let's look at a few other possibilities I might encounter, like something like this. Down at the bottom of the page, number 3. The difference here is we've got an actual coefficient for each of our terms. We haven't seen that yet. This one does have a funky variable. This is called beta. It's just a Greek symbol. So don't let that bother you. Just pretend it's an X or whatnot. But in this case here, I'm going to ask you to factor out the GCF. We do this a lot with our trig functions, and so let me just give you that hint and to get you started and see if you can do that on your own. Can you factor out the GCF between those two terms? I mean, I'm sure you can. So here's my first term. The addition is what separates the two. Here's my second term. What do they both have that I can take out? The 3, the number 3. Factor out the 3. And when I take it away from each term individually, I'm left with sine squared plus cosine squared. Now, hopefully at this point, that rings a bell. Yes, I do. Sine squared plus cosine squared is my most commonly used trig function or trig identity, and it's equal to 1, right? So I can substitute in place of this big parentheses. I know it's equal to 1. Copy down the rest of my expression and finish it off. My answer is 3. So it is possible for you to end up with a number as your answer. It might not always be a trig function. Okay, your turn. I would like for you to do number 2 all by yourself. I'm not going to give any hints. You do number 2 all on your own. Okay, so at some point, you might have gotten stuck with the cosine part. You're like, well, what? Or maybe you did it this way. Maybe did anyone do this? Like replace the cosine with 1 over secant. Say, replace cosine with 1 over secant. Since this comes first, you might have thought to do that and then seen, okay, well, my second term is secant of x. So let's say I just leave it like that. In the end, I'm still going to get the same simplified answer because I get a trig function over itself. And so my answer would be 1. Now, this is always going to happen when you multiply a trig function by its reciprocal pair. So if you notice that, when you are starting, if you notice, okay, it's cosine times secant, and those are reciprocal pairs, just like in anything we do, if we have 1/3 times its reciprocal, we're going to end up with 1. So trig function times its reciprocal is also going to equal 1. Occasionally we'll bump into that through our work. And let's take a look at one other example, and then we can move on. This last example here has us doing some multiplying. And I just need to make sure that we remember how to multiply two binomials like this. Maybe if I said FOIL, first, outer, inner, last, maybe that'll help us remember how to do that multiplying, or like distributive property. So let's go ahead and do that. Multiply your first terms. So 1 times 1. And then your outer terms, 1 times cosine. And then inner terms, we have, make sure to take the sign with it. So negative cosine times 1. Negative cosine times 1 would be negative cosine. And then your last terms, we have cosine times cosine. So I get cosine squared. Cosine times cosine is cosine squared. So let's clean this up and notice that my middle terms cancel each other out because that equals 0. I'm left with 1 minus cosine squared. And I want you to remind yourself when you see 1 plus or minus a trig function, almost all of the time you're going to use one of those 3 Pythagorean identities. So we have to figure out what 1 minus cosine, good. It's going to be sine squared. And so for this part right here, you have to recognize that it belongs as this identity, sine squared plus cosine squared equals 1. I need to get it into that form. So what happens is I'm going to have to subtract the cosine to the other side of the equation. And so it will be perfectly normal to kind of come out to the side and write down your identity and do the changes that need to take place in order to be able to know for sure what to substitute in place. So once I figure that out, I can put it in place of that. Alrighty. So, questions.